In this lesson, we're just going to kind of do a bonus lesson, simplifying radicals. If you remember how to do radicals, then you don't have to worry about it, but I would suggest you at least watch this video, make sure you get a good refresher, and then if you feel confident about it, you can go ahead and move on. But remember that if you do not have radicals down and you try to do them in decimal form or you try to give me non-simplified radical form, the answer will be wrong. So you need to make sure that you understand this before you move on. So first thing that I have here is at the very top we have this number line, okay, and this number line just gives us all the squares as well, okay, because like the square root of 1 is going to be 1, the square root of 4 is 2, the square root of 9 is 3. And the reason this is important is because whenever we're trying to simplify these radicals, we want to try to find the multiples, the factors that make in that number, whatever's under our radical, we want to try to find the highest square version of it in order to break it up and be able to simplify it quicker. So if we look at this first one, okay, my 393, I want to try to start at the numbers that are under 363 that could possibly go into it. So if I start on this right side, I'm going to first try 225. So if I do 363 divided by 225, I'm going to see if it gives me an exact number. So I do 363 divided by 225. It gives me a decimal. It gives me 1.61. So I'm going to say, nope, that one didn't work. So I'm going to keep going. So now I would do 363 divided by the next one, 196. Okay, so 363 divided by 196, decimal, doesn't work. Next one, divide by 169, okay, and you're going to keep going down, keep going through them all, so like if you cross them out as you go, so we did 225, we did 196, if I do 169, it's going to give me a decimal. I keep going until we get to 121, and so 363 divided by 121 gives me 3. So that means the factors of 363 are 121 and 3. So I can write this, instead of doing 363 as one whole radical, I can do it as the radical of 121 times the radical of 3. Okay, because this statement is exactly the same as the top one, the square root of 363. It's just broken up. I can break down into my factors and do the square root of each factor multiplied together. This is multiplication in the middle. And it's still the same exact expression. I haven't changed it. So now when I look at this, if I want to do the square root of 121, if we look at our number line up here, square root of 121 is 11. So I have 11, and then I still have the square root of 3. And so this would be my simplified answer. So if you look at our next one's a lot bigger. So what I'm going to do is I'm actually going to extend my number line. And I'm going to start here. That one ended with 15. I'm going to do 16, 17, 18. Because I think we're going to need a lot bigger. Because this is 3,000. I want to try to find the highest number. So we're going to see if we go up a little bit higher, maybe we can get a little bit closer. And I wanted to try to get to 25. So I'm going to extend it just a little bit longer here. So I got 24 and 25. So if I try to find my radicals of these, I'm just going to do 25 squared. So 25 squared is 625. So that means that my radical above it is the square root of 625. Gives me 25. 24 squared. It's going to be the square root of 576. And then just keep going. If I do the squares, then that means that the opposite. Okay, one thing to remember when we talk about radicals, when we talk about square roots, the opposite of square roots are squaring, and the opposite of squaring is square roots, just like how multiplication and division undo each other. Radicals and exponents undo each other whenever we're trying to solve and all that kind of stuff. So 23 gives me 529, and so forth. So I filled out the rest of mine here. I just have this one, the 16 is the square root of 256. 17 square root of 289, 18 square root of 324, 19 square root of 361, 20 square root of 441, 21 square root of 484, and so on. I'm sorry, actually I did that one wrong. This one, 441 is on the 221, and then I skipped it. Square root of 400 is 20. Okay, so if I look at my 3703, I'm going to start with my 25. So I'm going to do 37 03, and I'm going to try dividing it by that 625. The square root of 625 is my 25. I'm going to try to break it down into that one first. So if I do 3703 divided by 625, I get a decimal. So that one's not going to work. And so again, just like last time, I'm going to keep going. So I would do 576 next. So if I do 3703 divided by 576, I get a decimal again. So keep going until you find the right one. So as you keep going, when you get to 3703 divided by 529, which is the square of 23, it will give you 7. So that means that I can break it down into 529 and 7. So I'm going to break this. So I have square root of 521 times the square root of 7. Square root of 529, the square root of 529 is 23. So I get 23 square roots of 7 is going to be my answer. In this next one, okay, we're going to do the same thing with our number. Okay, so we'll start with the number 490. If you need to go back, you can look at, or at the top of your page, you can look at your number line. And so you need to start dividing 490 by everything that you think you can. So I have 490. And so as you keep going through the possibilities, when you do 490 divided by 49, you're going to get 10. Okay, so I can break this up into the square root of 49 times the square root of 10. Square root of 49 is 7, and so I still have the square root of 10. Okay, but if you notice, there's one thing that we left off here. We also have the square root of a to the 4th. Okay, so I'm going to put that here as well, times square root of a to the 4th. When I'm just doing square roots, okay, on variables, I can take out, if it's an even exponent, which in this case it is, then that means I'll be able to take out all of it, okay? But I can only take out half of them, okay? I can only take them out as pairs, okay? Because this is going to break down into 4 A's, right? That means I have A times A times A times A. When I'm taking the square root of something, I only get to take 1 from each pair, okay? So each of these pairs, I would put 1A out front, and this pair I'd put 1A out in the front. Okay, or like I said, if it's an even exponent, I just divide it by 2, and that's how many I get to take out. So I get to have 4 divided by 2 gives me 2. So that means I'm also going to be able to have the square root, I don't have an A anymore. I just have times. I said I take them all out in this case. So I just have A squared. Well, I don't want to leave this just off at the back because it's not under a radical anymore, so I need to move it to the front, but after my constant. So I'm going to have 7A squared square root of 10. Okay, if we look at our next one, I'm going to focus first on my number. So my 72, okay, the one that is highest that it will divide by whenever you start to look at it will be 36, and so that will leave you with 2. So I'm going to first break this up into the square root of 36 times the square root of 2. Then I also have the square root of A squared, and I have the square root of B to the 5th. So if I deal with my number ones first, my square root of 36 leaves me with a 6 square root of 2. And then my A squared, I have A to the 2nd, so it's even, so it means I'll take them all. So I just divide it by 2. So that means I'm going to just have an A outside. But my B is odd. Okay, so first when I have an odd, I'm going to go ahead. That means I'm going to be left with one of them underneath. And so if I subtract 1 from this, the one that I left, that gives me 4 left. So now my 4 I can actually divide by 2 just like my A. And so if I do 4 divided by 2, that leaves me 2. So I'm going to have B squared out front. Okay, that means that I was able to take 2 pairs of B's out from that. Because if I listed all my B's out, I would have B times B times B times B times B. I can only take 1 from every pair. So I have a pair here and a pair here. So that means I get 1B, 1B. But my ones that aren't paired have to stay underneath the radical by themselves. So this is where I got my B squared square root of B. Now I need to combine this all back together. So my ones that don't have any radicals on them, I'm going to put them after my constant at the front. So I have 6ab squared. And then I'm going to combine everything else back under the radical. So then I have the square root of 2 here. So I'm going to put my 2 there. And then I have a b. And so I'm going to put my b there as well. So this will be my final answer. This is simplified. The next section we look at adding and subtracting radicals. When we add and subtract radicals, it works a lot like variables, okay? Because the thing about when I have like 2x plus 3x plus y. Okay, I can only combine ones that have the same variables. So my 2x and my 3x I can combine and I can make 5x plus y. But my x and y, they're different, so I just leave it. I can't simplify it any further. Radicals work the same way. If I had the same radical, then I can combine them. So if we look at this first one, my ones that are the same, I have the square root of 5 and I have the square root of 5. So those two, I can combine the numbers in front. So if I look at it, I have 3 minus 2. So 3 minus 2 leaves me a 1. So I have 1 square root of 5. My square root of 7, there's no other ones like it, so I just have 2 square roots of 7. I don't need my 1 though. My 1s can just become invisible just like in front of exponents. So I can write this just as the square root of 5 plus 2 square roots of 7. Okay, not too bad, right? The only thing that this adds in is that then you sometimes will have to simplify it first. So in the second one, we need to look whether or not we can actually simplify 225. Square root of 10 doesn't simplify, okay, because the factors of it is just 2 and 5. I can't simplify either. Neither of those are a number that I can take the square root of evenly. So my 225 is the only one I'm going to look into. And so when you look at your chart, you should notice 225 is actually a perfect square. So we can do, so when we first simplify that one, I'm just going to leave the rest of it for now. I'm going to have 2 times, the square root of 225 is 15, minus my 6 square root of 10. I didn't change that part. So then I can do my 2 times 15. So 3 square roots of 10 plus 30 minus 6 square roots of 10. So I've simplified that portion. Now I need to combine ones that are alike. So I have my 3 square roots of 10 and my 6 square roots of 10. So I'm just going to add or subtract the numbers in front. So I have 3 minus 6. So 3 minus 6 gives me negative 3 square roots of 10. And then I have a positive 30. But typically we want to flip this. If you left this, it's okay. But it's better to have that positive number and then minus that negative number. And so this would be my simplified answer. 30 minus 3 square roots of 10. So in this next one, again, we're going to start off first with trying to simplify them. When I do 27, when I divide it by all my perfect squares, I can find that I have 5, and I'm going to have the square root of 9 times the square root of 3. Square root of 3 doesn't simplify, so the second one I'm just going to leave still. And then this last one, my 12, I can change it into the square root of 4 times the square root of 3. Okay, so now my next step, I'm going to go ahead and keep simplifying like we've done before. So I have 5 times the square root of 9 is 3 times the square root of 3. The second one, I can't change anything about it. Then I have plus 2 times, I have the square root of 4, so 2 times the square root of 3. I'm going to keep doing my multiplication, okay? Remember, order of operations, I do multiplication first, so I'm not worried about my addition and subtraction yet. So 5 times 3 gives me 15. The second one I'm still leaving alone. And then 2 times 2 gives me 4. So now, if you notice, they all have the square root of 3. So that means all of them, I can add and subtract the numbers that are in front, just like variables, as though they were all x's. So I have 15 minus 4 plus 4. Well, minus 4 and plus 4 are going to cancel each other out, so that means I'm going to be left with just 15 square roots of 3. Okay, this may have been hard to notice at first. In this first statement, it doesn't look like these two are going to cancel out. They look completely different. But when we simplify it starts to show us some of them are exactly the same. Okay, since this video is getting a little bit long, I'm going to briefly just show you just this number 1 of multiplying radicals. Okay, we've already kind of talked about multiplying because we've split them up to show, but whenever I multiply, all I do is I just multiply the numbers underneath. So this part I'm foiling actually, okay, or however you learned if you did box method. I always did FOIL, so I'm going to do my first term, so I'm going to do square root of 3 times square root of 5. Then I'm going to do my outsides. So my signs, I have a positive and a negative, so I'm going to have a negative, and then I have a square root of 3 times the square root of 2. Then I do my insides, so I'm going to have here, they're both positive, so I have the square root of 6 times the square root of 5, and then I'm going to do my last. And so I get a negative again, positive times negative gives me a negative, so I get square root of 6 times the square root of 2. So when I go to multiply these, all I do is I just multiply my numbers underneath my radical. So this one, 3 times 5 gives me 15, and then I keep my radical on it. And the next one, I'm going to keep my negative sign. I do 3 times 2 gives me 6, keep my radical. Next one, 6 times 5 gives me 30, keep my radical. 6 times 2 gives me 12, and again, keep my radical. Then in the next part, I need to simplify them first. Okay, well, square root of 15 only breaks down into 3 and 5. I can't simplify either of those, so I'm just going to leave it as square root of 15. Square root of 6, again, I can't simplify anything about that one, so it stays. Square root of 30, if you go through again all your perfect squares, you're not going to find any, so it's just square root of 30. But square root of 12 does break down, so we would do the square root of 4 times the square root of 3. And then we would simplify that part, so I'm going to leave all the rest of it. And so I do square root of 4 is 2, so I get minus 2 square roots of 3. And I can't simplify any further than that. Okay, none of these have the same radicals, so I just leave it as this whole statement. Like I said, I'm going to go ahead and skip these next two, and we're going to move on to the last part, dividing radicals. The main part about this is that we need to rationalize, okay? Rationalizing basically tells us that we can't leave any radicals in the denominator. Okay? It's just not considered something that we like in math. Okay, we can have them in the numerator all we want, but the denominator, they're just a no-go. Okay? So, when I look at this first one, I have 3 over the square root of 12. First, I'm going to go ahead and simplify. So, square root of 12, we know we can break up, so I'm going to leave my 3 on top. The bottom, I'm going to have the square root of 4 times the square root of 3. I keep simplifying it, and I'm going to go ahead and erase this part that I wrote. So you need to write it down somewhere, what it means to rationalize. Okay, so I'm going to leave my 3 on top still. Square root of 4 is 2, so I get 2 square roots of 3. Okay, but, like I just said, to rationalize, we don't like square roots in the bottom. We don't like radicals in the bottom at all. Okay, so the way to get rid of this is I'm going to multiply it by a factor of 1. Okay, because if I multiply something by 1, it doesn't change it, right? Okay, the way to get rid of it, though, is to multiply it by that square root of 3 to the top and the bottom. Okay, because anything over itself is equal to 1. So that means I'm not changing my problem at all, but when I multiply across, it will get rid of this square root. So let's look at this. So I do 3 times the square root of 3. I just combine them next to each other. I can't multiply under that radical because 3 isn't a square root on the first one. In my denominator, I still have my 2, and then I'm going to multiply the numbers underneath the radicals. So then I have 3 times 3 gives me 9. And now if you look at this, I have a perfect square in the denominator. So I'm going to leave my 3 square root of 3 on top. And then I have 2 times the square root of 9 is 3. So if I simplify again, I have 3 square roots of 3 over 6. But now notice I have a 3 divided by 6 that reduces. So then I can do one last step where I'm going to have just my square root of 3 in the top because this is going to reduce to 1/2. So it means I just have my 2 in the denominator. It is very important that you rationalize and get it to its simplest form. If you had given me like one of these other answers, these would have been wrong. Okay, like if you had given me this one, no. Okay, those things you have to get it to its most simplified. Okay, the second one I could suggest that you do on your own, and I'm happy to check it in class. We're going to go ahead and move on to one of these last ones. So this one I'm going to just try to simplify it, just each the top and the bottom. So if I think about just the top, I have the square root of 441. Okay, 441, let's try to find what it can be broken down into. And when you look at it, you should see that 441 is actually a perfect square, so I don't need my square root for that one. The square root of 441 is just 21. Then I would have the square root of a2. Remember that a2, since it's even, it means I'll be able to take all of it out, so I just divide the exponent by 2, so that means I'm just going to have an a. And then the bottom, I can't do anything about it. It's as simplified as it gets. 7 doesn't simplify b's alone, so it just stays underneath by itself. So now all we need to do is rationalize. So to rationalize, I'm going to multiply by whatever my radical is in the denominator to the top and the bottom. The whole thing. So on the bottom, I'm going to multiply by 7, the square root of 7b, and the top, the square root of 7b. Okay, remember this makes it 1, so I'm not changing the value of anything here. I'm just trying to rationalize, just getting that radical out of the denominator. So when I multiply across, I'm not going to combine anything that's not under the same radical, so I just have my 21a, and then I have my square root of 7b on the top. And in the bottom, I can multiply everything on the bottom. So I do 7 times 7 gives me 49. B times B gives me B squared. And so now if I do each of these individually, I have my square root of 49 and I have my square root of B squared. It's going to give me, if I just copy down my numerators, it's not changing. Square root of 49 gives me 7. Square root of B squared is B. Okay, and if you notice, whatever your radical is, that's what should be in the bottom, just with no radical, when you do rationalizing correctly. And so just double check on that if anything can simplify further, okay, especially your numbers. If you have multiple letters, you can always cancel out letters from top and bottom, and then numbers, try to simplify the fraction. So our 21 over 7 simplifies into 3 over 1. Okay, so that means I can change this and just have 3a square root of 7b over b, because I don't need that 1 in front. So this would be my simplified answer. If you need more practice on this, I have a practice paper. Just like I said, remember to move on. In the next sections, you're going to have to be able to complete a mastery check for me, to be able to show that you can do it correctly. If you do not rationalize, it's going to cause you to miss those problems. If you do not simplify, it's going to cause you to miss those problems. So make sure that you have this down. Otherwise, it's going to cause you a lot of headaches in the coming lessons.